Hi there, welcome to PCM. In this video tutorial, we will be studying triangles from NCERT. Especially, we will be studying some properties or some theorems. So let's start. In the previous video, we have learned that if the two triangles are similar, if their corresponding angles are equal and the corresponding side ratio is same, we have done this thing. So then we move on to, okay, so they are saying that the ratio of any two corresponding sides in two equiangular triangles is always the same. So it means that if we have a equiangular, so equiangular means this angle suppose is 30 and this angle is 30, and these two angles are also same with this one. So the ratio of this triangle sides to this triangle side will be same. So it is saying that only. Then we will start with this theorem. So the statement is, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the two sides are divided in the same ratio. So we have the triangle ABC, and we have made a parallel line DE to BC. So DE is parallel to BC. Okay. Now we need to prove that AD upon DB is equal to AE upon EC. This we have to prove, and so we will be doing some construction in order to prove this. We will draw DM that is parallel to AC and EN that is parallel to AB. So we are constructing this DM that is parallel to this AC and EN parallel to AD. Now just look at the area of triangle ADE. So the triangle AD is this one. ADE is this one. So area will be half into base into height. Here the base is AD and we have made a perpendicular, so its length is EN. Okay, so we have area of ADE is half into AD into EN. Area of, similarly in the same way we can calculate the area of this triangle B, D and E. In this triangle, okay, this triangle, the perpendicular is same in this case also, but the base is changed. It is changed to DB. Okay, so we can say that area of AD is half into AE into DM, and area of DEC is equal to half into EC into DM. Okay, so why we are saying this thing? Why we are saying this thing? So we are just changing the names only. Okay, so with this equation we get area of ADE upon BDE is equal to half into AD into EN upon half into DB into EN. So these all get cancelled and we just left with AD upon DB. Similarly, ADE upon DEC is AE upon EC. Now we know that the area of BDE and DEC are same. Why? The area of BDE, okay, let me clear this. They are saying that area of this BDE and DEC is same. Why? Because we know that DE is parallel to BC. So if we make a perpendicular from this to this, so its length will be, let's say its length is x, and we have the same base BC for both the case. So the area of triangle BDC will be half into BC into the length of height is x. Area of triangle BEC is also half into BC into x. So these two areas are same. Now as DEC, it was DEC. Yes, it is DEC. Okay, so I have to clean it. So it is DEC. So this thing and BDE. Okay. So in this the base is not BC. Okay, let me clean this away. Just a second. So they are saying that area of BDE is half into D into X, and area of DEC is also half into D into X, because the base DE is same. So we these two are same, then we equate and we get AD upon DB is equal to AE upon EC. So we have to just remember this thing, and it is very important to learn this thing. So we move on to this theorem number 6.2. So the statement is, if a line divides any two sides of a triangle in same ratio, then it must be parallel to the third side. Okay, so we will be proving this by contradiction. No, contradiction is not the correct word. Suppose we make a line DE dash that is parallel to BC. We are claiming that DE dash is parallel to BC. If this is true, then by previous theorem, we can say that ED upon DB must be equal to, it is D dash is parallel to BC. So AD upon DB must be equal to AE dash upon E dash into C. But we are given with this thing also. So equate these two things with these two equation, we get it is given, and okay, so we get this thing by using equation number 1 and equation number 2. We get AE upon EC is equal to AE dash upon E dash C. Now just add +1 to both sides. We will be getting EC plus AE upon EC equal to AE dash plus E dash C upon E dash C. Now what is EC plus A? Where is EC? EC is this one and A is this one. So it is complete AC. It is complete AC, and AE dash plus E dash C is also AC. Hence these two can be cancelled, and we just left with EC is equal to E dash C. Hence, which states dash E dash and E must coincide, means they are no two different points, they should be converge at one point. Okay, so we move on to this example number 1. It is saying that if DE is parallel to BC, we have to prove this thing. If DE is parallel to BC, we know that AD upon DB is equal to AE upon EC. This part we know. Now just reverse this, means this thing. We know that this, just reverse this means denominator, and just replace denominator with numerator and numerator with denominator. We get this thing, add +1 to both sides, we get DB plus AD is equal to, DB is this thing and AB is this thing, so it is making complete AB. So it is AB here, and similarly EC plus AE is AC, so it is AC here. Now just again interchange numerator with denominator and we will get the answer. Then we have this question. So in this, ABCD is a trapezium. A trapezium is the property of trapezium is that this AB and CD are parallel. Okay, so these are parallel with AB parallel DC, and EF are non-parallel sides AD and BC respectively, such that, and also EF is parallel to AB. It is given in the question, and we have to show this. In order to show this, let us do some construction. So we are joining A and C. Okay, now this EF is parallel to DC, so we get AE upon ED is equal to AG upon DC. Now look at triangle CAB, this triangle CAB. This GF is parallel to AB, so we get CG upon AG is equal to CF upon BF. So we are getting this now, which is just replace numerator with denominator, I mean interchange them, and we get this thing. Now let us name this equation 1 and 2, and from 1 and 2 we get AE upon ED is BF upon FC. Okay, so in the third question we are given that PS upon SQ is PT upon TR. Okay, and angle PS, this angle and this angles are same. So if this is true, then this imply by using theorem 6.2 that ST is parallel to QR. We have proved this in 6.2. So you can use this directly. You don't need to prove it here. You can just use the result directly. And we know that if there are two parallel lines and there is a third line which is intersecting these two lines, then this angle 1 and angle 2 will be same. This is the corresponding angle property. So apply this thing, which means that this angle and this angle must be same. Now we get PST is equal to PQR, and in question PST is given to PRQ, so PRQ is PQR. In a triangle, if these two angles are same, then it is an isosceles triangle, which means that if it is an ABC triangle, this side must be B and this one must be C. If these angles are same, then B must be equal to C. This is a property of isosceles triangle. Okay, so we have done with the examples. In the next video, we will be doing exercise 6.2. Until then, you can just learn how to prove theorem 6.1 and 6.2. And till then, read on.